Let us say, for example, that the ball was dropped from the top of the stairs. It will be then losing its potential energy as it approaches the ground or the 0 point position. Instead, the potential energy is transformed to kinetic energy. Kinetic energy is energy possessed by moving objects. It is affected by both the mass and the speed of the object. For example, a fired bullet, although relatively lightweight, have a lot of kinetic energy since it is moving very fast. Meanwhile, an overspeeding car is considered a road hazard due to its even greater kinetic energy. Another example is the rolling bowling ball towards the pin. The formula for kinetic energy is one half of the product of the mass and the speed squared. This means that while it is affected by both variables, the speed is the more controlling one. Let's say, for example, that you are in a bowling alley with your friends. You applied work on the bowling ball to make it topple the pins on the far end of the alley. It therefore has kinetic energy which it will use to do work on the pins. To avoid getting the ball to the gutter, you wanted to make the ball roll twice as fast. To do so, you must not only exert twice as much work, but four times as much. That is the compounding effect of speed squared. To end this video lecture, let us take a look at this swinging pendulum, which has both PE and KE at some points, and only either of the two in other points. If we take the central position as the zero height, the PE is therefore highest or greatest at both ends of the swing, as it is at the highest point at those points. Meanwhile, KE is least or zero at those points since the pendulum would stop for a while before swinging on the other side. However, as the pendulum approaches the central position, its potential energy decreases and turns into kinetic energy. The KE is greatest at those position or at that position, while PE is zero. This is a simple demonstration of how energy can be transformed from one form to another.